I've already told you what the derivative of the natural log of x is earlier. It's 1 over x, but I never gave you the proof for it. So I'm just going to let y equal the natural log of x, and we want to find the derivative of that. So what we're going to do is we're going to rewrite this in exponential form, because I can then say e to the y is equal to x, like that. And then I'm going to take the derivative with respect to x on both sides. Now this takes a little bit of chain rule to help us do this. E to the y is equal to d dx of x. Well, I'm going to run out of room, so I'll put it up here. So the derivative of e to the y, the derivative of e to anything is just itself, right? So I'm going to take, it's going to be on the left-hand side, e to the y, but using the chain rule, I have to take the derivative of y with respect to x, which is going to be dy dx. So that's using the chain rule. So this part here is the inner function, that is y, right? So that's going to give me e to the y, because the derivative of e to the x is e to the, or to e to the u is equal to itself, e to the u times du dx. In this case, it just happens to be y instead as the exponent. And then that's going to equal the derivative of x with respect to x is just 1. So then dy dx is equal to 1 over e to the y. But e to the y right here is equal to x according to our definition. So that means I can substitute in, instead of writing e to the y, I can substitute in x. So that means dy dx in this case is going to be 1 over x, just like we've proven before. The chain rule for the next one here, it's going to be 1 over u times du dx, or some people like writing it as u prime over u, like that. Let's try an example. Let's try two different ways of doing this then. If I want to find the derivative of the natural log of 2x, I have two options. One option is to rewrite it as an exponential, so I'm going to let y equal the natural log of 2x, like so. Then going to rewrite this as e to the y is equal to 2x. That's putting it in exponential form. Then take the derivative with respect to x on both sides. So e to the y, again, is equal to d dx of 2x. I'm showing that I'm taking the derivative with respect to x on both sides. On the left-hand side, I get e to the y times, using the chain rule, dy dx. I have to remember to take the derivative of the exponent. And then on the right-hand side, I just get the number 2. So then we get dy dx is equal to 2 over e to the y. But e to the y was equal to 2x. So that's going to equal 1 over x. Not negative there, 1 over x. All right, the other method now that we know the rule to take d dx of the natural log of 2x is going to be, okay, take 1 over u, and the u happens to be the interior function there, 2x. So it's going to be 1 over 2x, and then times the derivative of the interior function, which is just 2. And that simplifies to 1 over x. I feel like method 2 is a little bit faster and easier, and I think most people will be more comfortable using that. So try example 13. The only thing I want to point out is just be really careful for the third one here is a product rule. So I want you guys to try this on your own. Obviously, I'm hoping you're going to use the rule for natural log to do this. Pause the video and then you can check your answers. Pause now.